Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Rector of Universitas Airlangga, who in this event represented by Vice Rector for Academics, Student and Alumni Affairs, Professor Dr. Bambang Sektiari Lukiswanto, DEA DVM. The Honorable Dean Faculty of Veterinary Medicine, Universitas Airlangga, Professor Dr. Mirni Lamid, DVM, Master of Agriculture. The Honorable Vice Dean Faculty of Veterinary Medicine, Universitas Airlangga, Dr. Rimayanti, DVM, Master of Health. Dr. Iwan Sahrial Hamid, DVM, Master of Science, and Professor Dr. Mustafa Helmi Effendi, DVM, DTA PH. The Honorable Invited Speakers, distinguished guests, ladies and gentlemen. First of all, my name is Isaura Vita Yulinda. It is a precious chance for me to be your Master of Ceremony on this morning, on 11th of October 2022 in our big event, Second International Conference on Animal Husbandry and Life Science 2022. On behalf of the organizer, we would like to extend a warm welcome and express our gratitude for participating in this event. Ladies and gentlemen, this event is proudly presented by the Faculty of Veterinary Medicine, Universitas Airlangga. Before we start our event today, we will listening the Indonesian National Anthem, Indonesia Raya, and continue with Hymne Airlangga.
Indonesia kebangsaanku,
Thank you. Ladies and gentlemen, now we move to the next agenda. The next agenda is opening speech by the chairman of the Second International Conference on Animal Husbandry and Life Science 2022, Dr. Suzanita Utama, DVM Master of Philosophy. To Dr. Suzanita Utama, the time is yours.
Hello and welcome everyone. It is now 2 a.m. in Belfast and Nigeria, 10 a.m. in Japan and Korea, and 12 noon in Melbourne. So, is it still appropriate to say good morning? Thank you to each and every one of you for being here with us today. I am very pleased to be able to welcome Dr. Syamsul Ma'arif, MSc, DVM, Director of Veterinary Public Health from the Directorate General of Livestock and Animal Health of the Republic of Indonesia, Professor Dr. Bambang Saktiari Lukiswanto, DEA, DVM, Vice Rector for Academic, Student and Alumni Affairs of Universitas Airlangga, all invited speakers and all participants to the Second International Conference on Animal Husbandry and Life Sciences. Organized under the theme, The Development of Veterinary Medicine, Animal Husbandry, Human-Related Veterinary Science and Life Science in maintaining environmental balance post-COVID-19 pandemic. This program aims to provide a forum for all those interested in sharing and discussing common concern and current research in an effort to restore declining population and the genetic quality of animals contributed by the direct and indirect impact of COVID-19 pandemic. It is only through the exchange of the information that we can carefully develop strategic and medical intervention to solve this problem. This international conference is an annual program organized by the Faculty of Veterinary Medicine of Universitas Airlangga. And this is the second year program, which is held through an online live platform. Hopefully next year we can hold this program offline, where there will be more spaces for exchange and networking. To start this conference, there will be a keynote lecture delivered by Dr. Syamsul Ma'arif, MSc, DVM. Thank you very much, Doctor, for attending this conference and giving us the keynote address. In the plenary session, we will have our distinguished guests, Dr. Mulyoto Pangestu, Master of Reproductive Science, PhD from Monash University, Australia, Professor Gujang, PhD DVM from Seoul National University, Korea, Professor Simon de Graaf, PhD from the University of Sydney, Australia, Professor Mitsuhiro Takagi, PhD DVM from Yamaguchi University, Japan, Dr. Konita Kurnia Anjani from Queen's University, Belfast, UK, and also Professor Dr. Muhammad Laswardi, M.Pharm, DVM from Universitas Airlangga, that will share their knowledge and expertise to us. Thank you to all of you for accepting the invitation to participate in this program. To all participants, thank you for joining this program. The oral presentation of participants will be conducted in 4 parallel rooms under the topic of animal reproduction, animal husbandry and nutrition, pharmacy, and biological sciences. We will also have student poster presentation from which best 3 posters will be chosen. As the chairman of the committee, I would like to express our sincere gratitude and thanks to the Rector of Universitas Airlangga, Vice Rector for Academic, Student and Alumni Affairs of Universitas Airlangga, the Dean and all Vice Deans of the Faculty of Universitas Airlangga for their support, or otherwise it would be impossible to hold this program. The successful implementation of this program requires dedication and time from all committee members. Much work is being done to prepare this program. I am very grateful for your tireless help and support. Finally, I hope all participants can learn and adopt the new knowledge, find this program useful, and enjoy all its aspects. Thank you.
Thank you very much, Doctor, for the opening speech. Ladies and gentlemen, the next opening speech is from Dean of Faculty of Veterinary Medicine, Universitas Airlangga, Professor Dr. Mirni Lamid, DVM Master of Agriculture. To Professor Mirni Lamid, the time is yours.
Thank you, time for me. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Healthy greetings and good morning, everybody. Dear distinguished guests and all invited speakers, Rektor Universitas Airlangga, Profesor Dr. Muhammad Nasik SE, MT, AK, CA, represented by Vice Rector for Academic, Student and Alumni Affairs, Profesor Dr. Bambang Sektiari Lukiswanto, DVM, DEA. Dr. H. Syahrul Yassin Limpo, SH, MH, Ministry of Agriculture, Republic of Indonesia, who is represented by Samsul Ma'arif, DVM, Magister Science, Director of Veterinary Public Health from Directorate General of Livestock and Animal Health, Ministry of Agriculture, Republic of Indonesia. Vice Dean, Veterinary Medicine Fakulte, Universitas Airlangga, Surabaya, Indonesia. Dr. Rimayanti DVM, Magister Health, Dr. Iwan Sahrial Hamid DVM, Magister Health, and Professor Dr. Mustafa Helmi Effendi, DVM, DTA PH. Chairmen of Second International Conference on Animal Husbandry and Life Science, Susanita Utama PSD, Master Filosofi DVM. Dr. Mulyoto Pangestu, Magister Reproduction, PSD, from Monash University, Australia. Professor Go Chang, PSD, DVM, from Seoul National University, Korea. Professor Simon de Graaf, PhD from the University of Sydney, Australia. Professor Mitsuhiro Takaki, PhD, DVM from Yamaguchi University, Japan. Professor Dr. Muhammad Laswadi, DVM for Universitas Airlangga, Indonesia, and Dr. Konita Kurnia Anjani from Queen University, Belfast, UK. And to all the participants, I am Professor Dr. Mirni Lamid, DVM, Magister Agriculture, Dean of Veterinary Medicine, Fakultas Universitas Airlangga, Surabaya, Indonesia. On behalf of the organizing committee, it is my great pleasure to welcome you all to the International Conference on Animal Husbandry and Life Science. It is a matter of great pleasure that the Faculty of Veterinary Medicine, Universitas Airlangga, is organizing this conference for the second time, to be held through live online platform on 11 October 2020 at the Veterinary Medicine Faculty, Universitas Airlangga. We make this modern conference ready to transfer the valuable knowledge of veterinary sciences to all participants under the theme, the development of veterinary medicine, animal husbandry, human-related veterinary science and life science in maintaining environmental balance post-COVID-19 pandemic. This conference has become an annual international veterinary event for local and regional veterinarians to present and share their novel findings or approaches with the objective. First, to create space for presentation and discussion of current results of scientific work in the field of veterinary medicine. Second, to spread new knowledge, idea, and best practices to learn about the latest innovation and insights shared by special speaker invited. And the third, and to establish a new networking among researchers and related institutions to stay connected in their field. This year, several requested topics are including such as animal husbandry and nutrition, animal reproduction, biological sciences, and pharmacy. The public and consumers have far higher expectation for our vet professional today than they did in the past. We will all share responsibility for our lives and work to give all living things the highest possible quality of life. On behalf of the organizing committee, we would like to thank all sponsors, all honorable speakers, and all participants for the unconditional support. Without your contribution, this conference would not be possible. The organizing committee looks forward to warm welcoming you all and will do their best to make this conference an excellent forum for you all. Wabillahi taufiq wa hidayat. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Professor, for the opening speech. Now is the opening speech by Vice Rector for Academic, Student and Alumni Affairs, Professor Dr. Bambang Sektiari Lukiswanto, DEA DVM. To Professor Bambang Sektiari, the time is yours.
Thank you very much, Ms. MC. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes for all of us. Dr. Haji Syahrul Yassin Limpo, represented by Dr. Samsul Ma'arif, MSc DVM, Director of Veterinary Public Health from Ministry of Agriculture Republik Indonesia, also as keynote speaker in this conference today, the Honorable Dean of the Faculty of Veterinary Medicine, Universitas Airlangga, and Vice Deans, the Honorable Speakers, Dr. Mulyoto Pangestu from Monash University, Professor Gojong from Seoul National University, Professor Simon de Graaf from the University of Sydney, Professor Mitsuhiro Takagi, Yamaguchi University, Dr. Kodita Kunya Anjani from Queen University of Belfast, UK, and also Prof. Dr. Muhammad Laswardi, DVM from Airlangga University, and sure distinguished guests, ladies and gentlemen. Very good morning. It's a great pleasure, and on behalf of Rector Universitas Airlangga, Professor Dr. Muhammad Nasih, allow me to give a very warm greeting for all of you and welcome you all in the second International Conference on Animal Husbandry and Life Sciences. First of all, I would like to express my gratitude to the presence of all delegates, speakers, and participants on this conference, and a warm welcome to conference. Please allow me to invite the audience to express our gratitude to Allah Subhanahu wa Ta'ala for the gift and graces given so that we can attend this conference in a healthy state, safe and sound. Ladies and gentlemen, as we all know, changes in demand for animal production, reproduction, and all products of animal origin mostly occur due to human population growth, urbanization, and income growth. On the other hand, the production response in animal husbandry system is closely related to the development of science and technology to increase production and reproduction. Challenges in the future, production will be increasingly affected by the availability of natural resources, especially soil and water, environmental changes, by the need to operate in a carbon constant economy. Development in breeding, genetic engineering, the innovation of animal nutrition and health will greatly contribute to the increase in production as well as to produce livestock product of animal origin more efficiently. Ladies and gentlemen, as a world-class university, Universitas Airlangga encourages all its elements to take part in the advancement of science with impact on a global scale and to jointly solve local, national, and global problems. One of such endeavor is made by the Faculty of Veterinary Medicine, Universitas Airlangga. The Faculty of Veterinary Medicine, Universitas Airlangga is envisioned to become a leading faculty at the national and international level, a pioneer in the development of education and research in the field of veterinary medicine and animal husbandry, which is independent and innovative based on religious moral, ethic, environmental sustainability, and animal welfare while remaining oriented toward community welfare. With an orientation toward this vision, I expect positive and significant outcome to be gained from this international conference. Ladies and gentlemen, we look forward to the mutually beneficial partnership and collaboration that may arise from this event. In addition, this event is also expected to open new opportunities for the academic communities of the Faculty of Veterinary Medicine, Universitas Airlangga, and also the other participants, and to upgrade themselves with the new sciences developed. Therefore, once again, I hope this event will open new horizon for all the participants. May this second international conference on animal husbandry and life sciences also bring benefits to all of us, our nations, and global communities. Thank you very much for your kind attention. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor, for the opening speech. Ladies and gentlemen, before the main agenda, there will be a welcome dance by Student Unit of Traditional Dance and Music from Universitas Airlangga. Ladies and gentlemen, please welcome Traditional Dance Cendrawasih. Thank you very much for the great performance. Ladies and gentlemen, we move to our main agenda, which we are waiting for. The next agenda is keynote lecture and plenary session 1. In this session, we'll be guided by our moderators, Dr. Bilkisti Ariputra and Dr. Mirza A.M. Hisham. To the moderators, the time is yours.
Thank you, Mrs. Vida, and good morning for all attendees and participants. We will now enter the first speech session, who will be delivered by our invited keynote speaker. Ladies and gentlemen, please welcome Mr. Samsul Ma'arif, DVM, Master of Science. We are delighted to have here with you Mr. Samsul Ma'arif, DVM Master of Science. Good morning, Mr. Samsul Ma'arif.
Good morning, good morning.
I'm Bilkis. Today I will be the moderator for your speech this morning. And how are you today, Mr. Samsul?
I'm fine, I'm fine.
Okay, thank you, Mr. Samsul Ma'arif. And before we start, we would like to introduce our keynote speaker first.
Mr. Samsul Ma'arif, DVM Master of Science, graduated as a doctor of veterinary medicine from Universitas Gadjah Mada and got his master degree of development economics also from the same university. Mr. Samsul Ma'arif, DVM Master of Science, started his career in 1989 as a lead officer on Animal Health Center of Tanjung in Lombok, West Nusa Tenggara. After that, Dr. Samsul Ma'arif continued to serve as a lead officer on various government offices in West Nusa Tenggara. Dr. Samsul Ma'arif currently serves as a director of veterinary public health under the General Directorate of Animal Husbandry and Animal Health on Ministry of Agriculture, Republic of Indonesia.
Yes, there was a brief introduction about our speaker in this session. And Dr. Samsul Ma'arif will deliver the speech about 35 minutes. It's okay, Dr. Samsul Ma'arif. And
Okay.
now, without further ado, I would like to invite our speaker to give the lecture. And Dr. Samsul Ma'arif, the time and screen is yours.
Okay, thank you very much. I'm sorry, I'm use Indonesian, so I don't make mistake what I say. Terima kasih. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Tidak lupa semangat sehat. Pertama-tama saya ucapkan terima kasih atas waktu dan saya minta izin untuk menyampaikan arahan Pak Menteri. Nah, beliau seharusnya hadir, tapi karena ada kegiatan yang penting yang tidak bisa beliau tinggalkan, ya beliau meminta saya untuk mohon maaf, saya harus bahasa Indonesia yang saya khawatir nanti dari penyampaian arahan Pak Menteri. Pertama-tama yang saya hormati Bapak Rektor UNER, dalam hal ini oleh Rektor, terima kasih, kemudian Fakultas Kedokteran UNER dan para narasumber serta singkatnya para peserta kegiatan yang saya tidak bisa sebut satu Alhamdulillah di pagi ini yang bisa berkumpul atas rahmat dan hidayahnya, ya, sehingga kita diberikan kekuatan dan kesehatan untuk mengikuti atau mengikuti kegiatan the Second International Conference of Animal Husbandry and Life Science. Semoga Tuhan Yang Maha Esa selalu melimpahkan berkah dan hidayahnya kepada kita semua. Bapak Ibu sekalian yang saya banggakan, ketahui Indonesia atau Republik Indonesia merupakan negara kepulauan yang memiliki kekayaan keanekaragaman hayati yang sangat besar. Yang mega biodiversity itu merupakan sumber daya hewan dan tumbuh-tumbuhan. Sebagai anugerah sekaligus amanah Tuhan Yang Maha Esa, kekayaan tersebut perlu dimanfaatkan dan dilestarikan dalam mewujudkan kesejahteraan seluruh rakyat Indonesia. Bagaimana tercantum dalam pembukaan Undang-Undang Dasar 1945. Dalam rangka pemanfaatan dan melestarikan keanekaragaman hayati tersebut diselenggarakan oleh peternakan dan kesehatan hewan secara sendiri maupun terintegrasi dengan budidaya tanaman pertanian, perkebunan, perikanan, dan kehutanan dengan pendekatan sistem agrobisnis peternakan dan sistem kesehatan hewan serta penerapan asas pemanfaatan dan berkelanjutan. Kemudian keamanan dan kesehatan, kerakyatan dan keadilan, serta keterbukaan dan keterpaduan, baik itu dalam kemandirian, kemitraan, kemudian dengan keprofesionalitas. Kedua hal tersebut harus diselenggarakan secara sinergis untuk melindungi dan meningkatkan kualitas sumber daya hewan dan bagaimana kita menyediakan pangan yang aman, sehat, utuh, dan halal. Meningkatkan derajat kesehatan masyarakat, baik itu hewannya, kemudian termasuk pangannya. Kemudian menyediakan jasa dan bahan baku industri, dan mengembangkan ilmu pengetahuan dan teknologi. Serta kita meningkatkan pendapatan dan devisa negara. Dengan kita memperluas kesempatan berusaha dan kesempatan kerja, serta bagaimana cara kita meningkatkan kesejahteraan rakyat kita. Untuk mencapai tujuan penyelenggaraan peternakan, itu perlu dikembangkan wawasan dan paradigma baru yang peternakan agar investasi, kemudian inovasi, dan pemberdayaan di bidang peternakan terus berkelanjut dan meningkat sehingga meningkatkan daya saing bangsa dan kesetaraan dengan bangsa lain yang lebih maju. Sasaran pembangunan jangka menengah pada tahun 2020 dan sampai dengan 2004 atau Presiden kita, bagaimana kita mewujudkan masyarakat Indonesia yang mandiri, maju, adil, dan makmur melalui percepatan pembangunan di berbagai bidang dengan menekankan terbangunnya struktur ekonomian yang kokoh yang berdasarkan atau berlandaskan keunggulan kooperatif dan kompetitif di berbagai sektor ekonomi dan budaya. Itu yang tertuang dalam RPJM pemerintah kita yang sekarang ini. Kemudian pembangunan nasional itu didukung oleh kekayaan sumber daya alam. Kemudian sumber daya manusia yang berkualitas dan ditopang dengan teknologi maju dan kelembagaan yang terkonsolidasi sehingga mampu menghasilkan produk yang berdaya saing dan berkelanjutan sesuai dengan RPJM 2020 dan sampai dengan 2000. Pembangunan sektor pertanian masuk subsektor peternakan arahkan untuk mendukung prioritas nasional yang pertama, yaitu penguatan ketahanan ekonomi untuk pertumbuhan yang berkualitas dan berkeadilan dengan program prioritas peningkatan ketersediaan, akses, dan kualitas konsumsi pangan secara nasional. Itu yang tertuang untuk subsektor peternakan. Dari berbagai kontribusi Kementerian Pertanian terhadap prioritas nasional dan terhadap program prioritas, Direktorat Jenderal Peternakan dan Kesehatan Hewan itu berperan untuk ketersediaan protein hewani, kemudian peningkatan produksi daging, kemudian keamanan pangan asal ternak, serta penerapan teknologi dan ekspor produk peternakan. Sedangkan untuk peningkatan kesejahteraan peternakan, melihat dari pertumbuhan pendapatan domestik peternakan dan nilai tukar petani. Sebagai penjabaran arah kebijakan nasional dalam RPJMN 2020-2024 ya, dan Renstra Kementerian Pertanian tahun 2020-2024, kebijakan peternakan dan kesehatan hewan diarahkan untuk mendukung ketahanan pangan, kemudian untuk pertumbuhan ekonomi dan kesejahteraan peternak, serta berkelanjutan sumber daya peternakan dan kesehatan hewan. Dalam rangka mewujudkan visi misi dan Renstra Dirjen Peternakan dan Kesehatan Hewan pada tahun 2020 sampai dengan 2024, itu ada dilakukan revisi kedua dengan 38 tujuan dan sasaran pembangunan. Maka Dirjen PKH menetapkan 4 arah kebijakan ya, dan strategi yang diambil dari 38. Yang pertama, kebijakan yang kita ambil, kebijakan strategi yang diambil adalah penyelenggaraan peternakan yang sesuai dengan good breeding and good farming practice. Adapun strategi pelaksanaan kegiatan dilakukan melalui penyediaan benih atau bibit ya, dan peningkatan produksi ternak yang berkualitas dan berkelanjutan. Penyediaan pakan yang berkualitas, kemudian aman dan berkelanjutan dengan mengoptimalkan pemanfaatan bahan bakan lokal, serta pengolahan usaha peternakan yang terintegrasi dari sampai ke hilir. Itu yang pertama. Kemudian yang kedua, itu peningkatan nilai tambah dan daya saing produk peternakan dan kesehatan hewan. Adapun strategi pelaksanaan dilakukan melalui peningkatan nilai tambah produk peternakan, melalui pengolahan hasil peternakan dan pengembangan peternakan organik. Dan melakukan peningkatan daya saing produk peternakan melalui pengembangan investasi, kemitraan, kelembagaan peternak, fasilitasi prasarana dan sarana pemasaran hasil peternakan, kemudian promosi peternakan dan kesehatan hewan, pengembangan pemasaran dalam dan luar, serta pengembangan sistem pengolahan dan pemasaran. Ini yang kedua. Kemudian yang ketiga, kita melakukan pengolahan kesehatan hewan dan kesehatan masyarakat veteriner melalui pengolahan kesehatan hewannya itu sendiri. Tujuannya untuk menjaga dan mengendalikan kesehatan hewan agar terbebas dari penyakit hewan. Kemudian pengolahan kesehatan hewan dilaksanakan melalui pengendalian dan penanggulangan penyakit hewan. Kemudian pengolahan obat hewan serta alat dan mesin kesehatan hewan. Dalam pengolahan kesehatan masyarakat veteriner itu berkontribusi dalam menjaga kesehatan masyarakat dari penyakit asal hewan. Kita tahu 60% penyakit patogen yang ada pada manusia itu berasal dari hewan. Kemudian pengolahan kesehatan masyarakat veteriner itu dilaksanakan melalui pengendalian dan penanggulangan zoonosis. Kemudian penjaminan keamanan pangan, kemudian kesehatan, keutuhan dan kehalalan produk hewan itu. Dan kemudian kita menjamin izin dan sanitasi serta pengembangan kedokteran dan perbandingan. Nah, di dalam kegiatan kita yang di atas itu diikut sertakan khususnya dalam kesehatan masyarakat veteriner ini adalah penanganan bencana yang berdampak pada hewan. Jadi kita mengarah kepada kesejahteraan hewan. Dalam suasana bencana, teman-teman di NPB itu akan menangani manusianya, tapi kami dari Dijen Peternakan dan Kesehatan Hewan, khususnya di Direktorat Mapet, itu akan menangani hewannya. Kemudian yang terakhir, yang keempat, itu tata kelola pemerintahan yang bersih dan akuntabel. Nah, strategi pelaksanaan itu dilakukan melalui bagaimana kita mengoptimalisasi pelaksanaan reformasi birokrasi Direktorat Jenderal Peternakan dan Kesehatan Hewan itu dalam mendukung pelaksanaan reformasi birokrasi Kementerian Pertanian. Itu yang kita ambil langkah-langkah kebijakan untuk RPJM tahun 2020 sampai dengan Bapak Ibu sekalian atau hadirin yang kami hormati, saat ini sektor pertanian telah terbukti yang memiliki ketahanan yang kuat dan tangguh, serta tetap tumbuh positif walaupun 2 tahun terakhir Indonesia dilanda pandemi COVID-19, sehingga PDB sektor pertanian triwulan pertama tahun 2022 itu tumbuh 21,69%. Ya. Di saat sektor lain sedang terpuruk. Nah, sektor pertanian tetap konsisten tumbuh positif. Daya beli petani juga terus membaik. Hal ini terlihat dari indikator nilai tukar petani selama triwulan pertama tahun 2020 itu tetap tinggi. Di bulan Juni 2022 itu mencapai 105,96 atau naik 0,52% dibandingkan Mei tahun 2020. Nah, pada masa mendatang sektor pertanian termasuk subsektor peternakan akan tetap memiliki peran penting karena selain menjadi penyedia pangan penduduk juga sebagai penopang utama pertumbuhan ekonomi. Selain itu, sektor pertanian juga dituntut sebagai sumber pendapatan rumah tangga, penyedia lapangan kerja, kemudian dan menjadi penghasil devisa negara. Jadi ada 3 tuntutan yang diinginkan, bagaimana sebagai sumber pendapatan utama rumah tangga, kemudian penyediaan lapangan kerja, dan menjadikan devisa negara. Bapak Ibu sekalian yang saya banggakan, adapun kinerja peternakan sampai dengan triwulan kedua tahun 2022 itu meliputi BDB peternakan pada triwulan kedua tahun 2022 tumbuh sebesar 3,56%. Ini year on year ya. Di saat PDB pertanian tumbuh 1,37%. Dan kemudian di PDB nasional itu 5,44%. Investasi peternakan pada semester pertama tahun 2022 untuk yang penanaman modal dalam negeri itu tumbuh sebesar 53%. Sedangkan penanaman modal asing tumbuh sebesar 478,8%. Ini perbandingannya. Kemudian nilai ekspor peternakan itu kita ambil dari Januari sampai dengan Agustus tahun 2022 itu tumbuh sebesar 4,80. Sehingga nilai tukar petani peternak sampai dengan September 2022 sebesar 101,68% atau naik 2,52% year on year. Bapak Ibu sekalian yang saya banggakan, persoalan pangan itu menjadi permasalahan krusial yang harus diwaspadai. Saat ini sudah ada 22 negara yang menghentikan ekspor berbagai jenis pangan untuk mengamankan kebutuhan domestik di tengah ketegangan geopolitik dunia. Krisis pangan global yang terjadi saat ini disebabkan oleh pembatasan ekspor yang dilakukan beberapa negara guna menjaga stok pangan di dalam negeri masing-masing. Indonesia saat ini juga tengah mempersiapkan rencana besar dalam mendorong diversifikasi pangan dalam rangka menghadapi krisis pangan global, termasuk untuk melakukan optimalisasi komoditas peternakan yang ada, terutama ternak-ternak lokal kita. Selain itu, sehubungan dengan populasi manusia di Indonesia yang terus meningkat, ya, di tahun 2020 itu mencapai 269,6 juta jiwa, itu berdasarkan data BPS, serta penggunaan lahan pertanian yang semakin luas menimbulkan adanya peningkatan interaksi antara manusia, satwa liar, dan ternak hidup. Dampak dari zoonosis ini bisa menimbulkan beberapa kerugian, di antaranya yang pertama itu akan mengancam kesehatan hewan, kemudian timbulnya penyakit pada hewan mengakibatkan penurunan produksi dan kematian ternak. Jadi sekarang kita lagi ngalami, mohon maaf, walaupun ini bukan kemudian yang kedua itu kerugian ekonomi, itu mengancam sumber mata pencarian dari peternakan. Kemudian yang ketiga, itu menimbulkan kematian dan penyakit pada manusia yang berdampak pada ekonomi. Dan selain isu global yang berkembang lainnya dan juga menjadi perhatian adalah masalah resistensi antimikroba yang diprediksi akan menjadi pembunuh nomor 1 di dunia pada tahun 2050. Dengan tingkat kematian mencapai 10 juta jiwa per tahun. Dan hampir setengahnya terjadi di kawasan Afrika. Kita lihat, kalau kita perhatikan di Afrika saja 4, sekian juta. Kalau di Asia sekitar 4,7 hanya kepada negara-negara yang. Nah, dalam beberapa dekade terakhir, laporan di berbagai negara mencatat peningkatan laju resistensi antibiotik. Namun di sisi lain, penemuan dan pengembangan jenis antibiotik baru hampir tidak ada. Dengan kata lain, pola peningkatan laju resistensi sudah berbanding terbalik dengan penemuan obat antimikroba. Hal inilah yang menyebabkan mengapa resistensi antimikroba berkembang menjadi isu global yang dibahas dalam berbagai forum internasional. So, pertemuan di G20 yang sekarang ini. Dan dipandang sebagai salah satu ancaman yang paling serius bagi keberlangsungan kesehatan manusia. Khususnya di sektor peternakan dan kesehatan hewan, harus disadari bahwa ancaman resistensi antibiotika itu tidak hanya mengancam keberlangsungan kemampuan dalam mengendalikan penyakit infeksi pada ternak, akan tetapi juga sangat mengancam keberlangsungan ketahanan pangan, terutama keberlangsungan produktivitas sektor peternakan dalam menyediakan sumber pangan hewani masyarakat. Bapak Ibu sekalian yang saya banggakan, saat ini kita juga sedang berjuang dengan berbagai langkah untuk penyelesaian penanganan pengendalian penyakit mulut dan kuku. Saat ini juga dalam pelaksanaan kita lakukan adalah vaksinasi. Kemudian teman-teman di Kementan telah mendistribusikan vaksin yang dilakukan secara bertahap dengan target populasi yang pertama adalah ternak aset dan ternak dengan nilai ekonomi tinggi, sapi, kerbau, kemudian sapi perah dan sapi bibit, dan sapi yang berpotensi tinggi untuk dilalu lintaskan di provinsi yang berdampak. Yang menjadi kekhawatiran kita adalah karena kita Indonesia kaya dengan plasma nutfah, sehingga yang kita khawatirkan kalau ini semua akan musnah, kita akan sulit untuk mendapatkan pengganti dari plasma nutfah ini. Kali sapi Jawa dan sapi Madura dan lain sebagainya. Selain itu, sesuai arahan Bapak Menteri Pertanian ya, dalam rangka penanganan dan pengendalian penyakit mulut dan kuku, ada 5 hal yang harus diperhatikan. Antara lain, 1, melakukan vaksinasi ternak sehat yang rentan terhadap penyakit mulut dan kuku. Kedua, menjaga sanitasi dan biosecurity kandang. Kemudian ketiga, mengatur dan membatasi lalu lintas ternak dan produk ternak. Yang keempat, mengisolasi ternak sakit dan ternak baru. Yang terakhir adalah bagaimana kita melaksanakan stamping out atau pemusnahan ternak sakit, atau yang kita biasa tidak menggunakan stamping out, tapi kita melakukan pemotongan bersyarat.
Excuse me, Dr. Samsul Marif.
Okay.
I would like to remind that your time
just a minute.
is you have 2 minutes more.
Oke.
Okay.
Ini pun kami dibantu oleh pelaksanaan kerjasama itu oleh Pemda, kemudian ada BNPB, TNI, Polri, dan kementerian lain yang terlibat, masuk Kemendagri. Dalam pelaksanaan vaksinasi, itu disampaikan, itu sudah kita lakukan vaksinasi sebesar 3 juta, hampir 4 juta ekor. Itu tidak cukup sampai dengan langkah tersebut. Saat ini Kementan telah mengalokasikan termasuk pergantian ternak yang dalam bentuk bantuan pemerintah itu sebanyak 15.000 ekor dengan harga per ekornya untuk sapi 1 juta, kemudian kambing domba 1,5 juta, dan kalau babi, dampak kematian babi itu 2 juta. Saat ini Kementan telah menargetkan agar wilayah merah khususnya terendah secepatnya menyusun strategi yang efektif dan berkelanjutan untuk relevan ke arah zero case. Ya. Bapak Ibu sekalian, yang saya banggakan terkait dengan upaya pembangunan peternakan Indonesia, tentunya masih ditemukan berbagai kendala dan permasalahan. Namun demikian, pemerintah pusat dan pemerintah daerah bersama-sama dengan stakeholder lainnya berupaya untuk dapat menyelesaikan permasalahan tersebut. Selain peran pemerintah dan mengatasi permasalahan kesehatan masyarakat veteriner, keterlibatan masyarakat dan stakeholder yang lain terkait, termasuk akademisi, itu merupakan salah satu kunci utama keberhasilan pembangunan di bidang Keswan dan Kesmafet, terutama pembangunan Kesmafet di Indonesia. Oleh karena itu, kami sangat mengapresiasi dan menyambut baik kegiatan ini sebagai upaya perguruan tinggi dalam mendukung pemerintah dalam pembangunan peternakan di Indonesia. Hadirin yang kami muliakan, Kami menyadari bahwa segala upaya yang dirancang dan direncanakan tidak akan optimal dalam mengimplementasinya tanpa peran seluruh pemangku kepentingan yang terkait. Maka dari itu, dalam kesempatan yang baik ini, secara khusus kami berharap kepada perguruan tinggi dapat ikut berperan sebagai bagian dari solusi dalam mendukung pembangunan peternakan dan kesehatan hewan di Indonesia. Tantangan yang dihadapi harus dipandang sebagai kewajiban dan tanggung jawab kita semua. Untuk itu, kita harus senantiasa berupaya meningkatkan kompetensi profesional kita semua. Demikian yang dapat saya sampaikan. Selamat mengikuti kegiatan dan semoga acara ini dapat berjalan lancar. Demikian, terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Samsul Ma'arif, for the excellent brief.
Thank you very much.
But before we end this session, may I summarize from Dr. Samsul Ma'arif speech? And from the explanation, organizing the agricultural sector in the national development is the key success to realize the dignity, resilience, progress, justice, and prosperity of the country. And Ministry of Agriculture play important role as a defense system of our country regarding public health, food safety, and food sustainability. That's all the summary for this session. And again, we would like to express the gratitude for Dr. Samsul Ma'arif, Master of Science, for sharing his time and expertise with us, and would like to present this certificate as a token of appreciation.
Okay.
Thank you, Dr. Samsul Ma'arif.
Okay.
And if you have another agenda to attend, it's okay to leave the meeting, and it's a pleasure to have you this morning with you. Thank you, Dr. Samsul Ma'arif.
Terima kasih.
Thank you,
Ibu
Doctor.
sekalian, mohon maaf saya akan keluar.
Thank you, Dr. Samsul.
Okay, now for our participant, we are very excited to inform that we will start the first plenary session for today. For this session, I would like to invite our first speaker. Ladies and gentlemen, please welcome Dr. Mulyono Pangestu, Master of Reproductive Science, PhD. So we are glad to have Dr. Mulyono Pangestu joining us today. How are you, Doctor?
Good. Thanks for inviting me this morning. So I would like to thanks for the organizing committee.
Yeah, how's the weather in Australia?
It's nice, warm today. We just have a meeting outside. It's about 18 degrees outside.
Oh,
so
yeah, it's
quite
pretty cold, yeah.
cold for Surabaya, but
Yeah.
yeah.
Okay. Okay, before we start, I would like to briefly introduce our speaker for this session.
Dr. Mulyono Pangestu currently is lecturer in Department of Obstetrics and Gynecology, Monash University, Australia, and got his bachelor degree in animal husbandry or animal science from Faculty Universitas Jenderal Sudirman on 1987, and got his master degree from Reproductive Science Education Program from Faculty of Medicine, Monash University, Australia. Then his PhD degree from Monash Institute of Reproduction and Development, Faculty of Medicine, Monash University, Australia. And his research interest is on obstetric and gynecology, and he also currently has 30 Scopus Index papers with 200 more recorded citation and 9 age index.
That is all about our speaker for this session. Dr. Mulyono Pangestu will deliver a lecture about challenge of in vitro embryo production in Indonesia and its future prospects in about 35 minutes. Now I would like to invite our speaker to deliver the lecture. Dr. Mulyono Pangestu, please sir, the time and screen is yours.
Thanks. First, I would like to thanks to the organizing committee for inviting me. I've been working together with Faculty of Veterinary Medicine, Airlangga Universities, I think it's quite a while, since Professor Masud and then Dr. Susanita was there, and then was so it's I've been there few times to Surabaya. This morning I would like to give my presentation about in vitro embryo production in Indonesia, the prospects and challenge. Can go to slideshow. Share screen. Can you see my presentation? No,
Yes, very clearly.
Wrong one. Not this one. Sorry, it's wrong one. Share. Slideshow. Oh yeah, on the other side. Okay. Okay. Good morning, everyone. My topic today is about in vitro embryo production in Indonesia, challenge and prospect. So, if we look at animal reproduction, all animals do their reproductive activity. So, when the nature calls, the animals go, they have their own copulation. They prepare to create a new generation of the animals and everything. The only problem with this one is human do not have more control on when the animal gonna be mated or everything, because the animal they got their own system. As we were they got estrus system, and the male always ready, but the female have to go through their breeding season. Fortunately, we are in Indonesia. We're living in a tropical area. If we live in a subtropic like in Australia, Europe, or America, in northern hemisphere or southern hemisphere, we know that those animals they won't breed if they're not in their breeding season. While in Indonesia, the animal couldn't recognize their breeding season because the photo period in Indonesia relatively similar from day to day within a year. So if you look at this one, like where the animals do their reproductive activity, first they need to maintain their existence in the universe. If animals fail to reproduce themselves, then of course they will disappear or they'll no longer exist in the world. On the other hand, we know that there is an estrus, or this is a period where the female ready to have sexual activity with the male. These times are very critical for animal reproduction because without estrus, the animal won't do their reproductive activity, especially mating and pregnancy. So some animals, they got their seasonal breeding season, like in northern or southern hemisphere. And there is a natural mechanism, which is the animal will give birth or deliver their offspring when there is plenty or abundant food available. So whatever animal, if we look at the animal living in a northern or southern hemisphere, they will have their breeding season in different timing, but most of them will deliver giving birth during the springtime. So for instance, for cattle, the pregnancy time is about 9 months. So we just calculate back from springtime, 9 months back, so it falls in summertime. That's why we call it cattle as a long day breeder. On the other hand, like sheep, goat, we call it short day breeding season because their pregnancy only 5 months. So if they want the lamb or the offspring born in springtime, so they have to start their reproductive activity sometimes in May or April, which falls in autumn, which is the day shorter than the night one. So the animal recognize their photoperiod through the sunlight going through their eyes and then process to their central nervous system. So they know when I should start my reproductive activity. On the other end, human intervention such as farming is not always altering the breeding season. We expect that every farm animals will lose their breeding season pattern. Unfortunately, like for dairy farmers, they still live in a traditional way, which is like in Australia. Most of their calf born in starting from September until January. So if you look at the production, means during June and July, we call it a dry season for milk production. So sometimes the farmers have to modify the breeding season, such as give the hormonal stimulation to alter the breeding season, or they intervene further by doing embryo transfer, such as flushing the embryo from the cows or from the cows. So this activity has been quite common in many countries in the world, and Indonesia has been starting through ballet embryo transfer Ciplang, but the productivity or the production activity is not as much as other farm or other center in America, Europe, or Brazil. So when we look at this one, we know that human can interfere the reproductive activity of farm animals. And if you look at back, the history is quite wild. I mean, the history of artificial insemination itself is starting from 17th century. Even though they start using for sheep farm in Russia around 19th century, but artificial insemination is the eldest technology that's been used by human being. So, about starting in, especially after 1949, when we found the protocol for freezing bull semen, so artificial insemination become booming in farm industry. On the other hand, now we're not just doing artificial insemination, but we're also doing embryo transfer. So if you look at artificial insemination, we distribute the superior genetic material through the male side, through the semen. So sometimes we have to run what we call it now progeny testing, which is we're not really doing anymore. It takes longer. So sometimes progeny testing lasts for about 4 to 6 years. But with embryo transfer, we can see the result faster than artificial insemination. Embryo transfer start since 80s, 60s, 80s when Stein Willadsen and their team able to put grow a rabbit embryo outside the body and then put it back. But beyond that one, then we start doing in vivo derived embryo. So instead of transfer straight away, so they try to create embryo in vivo from the cows. This involves superovulation, mating, flushing, sometimes they go embryo freezing and embryo transfer. What we do in Ciplang is the in vivo embryo production, but this protocol not always feasible, I mean not always available or viable for the farmers. So to increase the production, some other farmers, some other scientists try to develop in vitro embryo production. The first protocol they develop are using oocyte collected from abattoir, from the ovaries, or from live cows, and then they move further, getting oocyte from young cattle. So this protocol, they call it GFAT, juvenile in vitro embryo transfer. So they aspirate the oocyte from the ovary of a young cow or from the calf, female calf, then they grow them and develop into an embryo. further development of embryo production, cloning or non-generative embryo production. I won't discuss this one, but it's going to be interesting story since the born of Dolly and the success of Korean group in cloning dog and many other animals. So, when we discuss about in vitro embryo production, there are a few steps that commonly done when we do embryo production. First is after we collect the oocyte, we do the in vitro maturation. Why? Because we got the oocyte from antral follicle, which is the oocyte are immature. So we call it a COC or cumulus oocyte complex. So this one need to be mature to get it ready for fertilization. Either the oocyte come from the aborted ovaries or transvaginal ovum pickup. The next step is sperm capacitation. This when after we do in vitro maturation, this is about 22 or 24 hours. And then when the eggs ready for fertilization, we put another step is sperm capacitation or selection, which is we spin down the sperm using a Perkol gradient to get the good quality sperm. Once we got the sperm ready, then we do in vitro fertilization, which is we inseminate the sperm into the clump of the egg, then let the eggs fertilize by the sperm, then they grow into an embryo. When we finish the in vitro fertilization, this for in some lab they run it for overnight, but some other only run it for 6 to 7 hours. Then they do in vitro embryo culture, which is growing the embryo from fertilized oocyte until they reach blastocyst. From then, they either freeze the embryo, then send it somewhere else, or they use it later, or they got the recipient ready to receive the embryo transfer. So on the top of that, they got embryo transfer and cryopreservation. Each step of this protocol need a different media. Like in vitro maturation, we need a media like a TCM199 plus hormones, and should be done in an incubator with 5% CO2. Sperm capacitation using Perkol gradient 80-40 or 90-45. But this can be done at room temperature. Well, in vitro fertilization is another steps that need different media and should be done inside the incubator. The same as embryo culture, which is need culture media and also need incubation in 38 degree with 5% oxygen and 6% CO2. Well, embryo transfer and cryopreservation another steps which need another skills like now vitrification very popular, but some other cattle embryo producer or in vitro embryo, they're still using slow cooling to freeze the embryo. Once the embryo ready, we can send it anywhere, or we can keep it sometimes until we got the recipient that's suitable to receive embryo transfer. So if you look at on this diagram, it's just try to repeat what I mentioned earlier. The in vitro embryo productions can be done through collecting oocyte from adult cows or from juvenile cows. That's what we call it transvaginal ovum pickup. If we got it from abattoir, then we do aspiration from the ovaries. We aspirate, then we got the immature egg. The good egg for embryo production, if they do have at least 3 layers of cumulus cells, then we put them for IVM on the next day. The cumulus cells expand and looks very sticky like a mucus, and they're ready for fertilization. In other steps, there is the frozen sperm. We thaw them, prepare it, mix with the egg to fertilization. Then we culture the embryo from 1 cell up to blastocyst. So the process itself is similar for either we got from abattoir, from juvenile, or from adult one. Now, what's happened if we do the abattoir-derived embryo? Oh, sorry, abattoir-derived oocyte. This is a very common practice in some countries. And it's very simple because what we need just go to abattoir, collect the ovaries from the cows after they slaughter the cows, and then bring it to the lab in warm normal saline, wash them, clean up from the blood, and then we aspirate the follicles. Go back to we aspirate the follicles. These the follicles using 18 or 19 gauge needle connected to either vacuum pump or to 3 mils injection syringe. Once we got that one, we will see the COC. Then we put it away. We put them all together in IVM media. Then we run IVM. The problem is, I'm not saying it's a problem because this part of the government try to control to increase the population of the cows. The Article 18 of the paragraph law number 41, 2014, regarding the law number 18 year 2009 on animal husbandry, that slaughtering cow can be illegal and prosecuted if the cows do not fit some criteria. First is should be more than 8 years old or giving birth 5 times. The cow is infertile, like after tested by the veterinarian. This badly injured, they got genetic issue, they got disease, or become very wild or uncontrolled and injure human life. Those conditions kind of limit or prevent or restrict the in vitro embryo production from abattoir collected ovaries. Even though we got some animal infertile, we might not get a good quality egg from this animal. Or the animals got injured, it might be bad for the health condition. If they got genetic issue, we don't want to distribute or disperse their genetic problem to the offspring. They got infectious disease, we don't want this to come up. Uncontrolled or endangered human life, it might be hard to control this animal. So, from many discussions with my colleagues in Indonesia, it looks like this abattoir-derived embryo, I'm not saying almost impossible, but it's a bit difficult to develop in Indonesia. Even though there are some abattoirs still killing or slaughtering some cows, but it's not always is the best interest, or not every city, every place has got this. I mean, they got their facility. They got good number. Even though some friend told me they are in some eastern Indonesia, they slaughter the female and everything, but it doesn't convince me to develop a lab in that area. So, as an alternative, we might go to in vitro embryo production through transvaginal ovum pickup. This protocol is non-invasive, can be done on juvenile calf or in adult cows. There are few papers showing this protocol anywhere, and this become a common practice in a farm with excellent cows. So I can tell you a story. If a farmer's got like say 50 liters milk per day from a cow, then this farmer's not thinking to sell the milk. Instead of selling the milk, the farmer's gonna thinking about selling the embryo from that cows, either through in vivo embryo production or using in vitro or transvaginal ovum pickup. Why? Because the price of the embryo generated from this cow is a lot more expensive than the price of a milk. I can mention that some embryos cost about 4,000 to 5,000 Australian dollar. It's equal of the price almost 1,000 liter of milk. So if one flushing that cows produce say 10 embryos, regardless the gender of the embryo, so in one go to farmers gonna be taking about $50,000. It means a lot more than the milk production for a year. The transvaginal ovum pickup can be done weekly or every 2 weeks and produce high quality offspring from high quality cows, and sometimes they don't need superovulation. So this technique is quite common in some countries, like a country like Brazil. They do this in vitro embryo production through ovum pickup almost every day. There is one farm in Brazil that running this production, and they're able to sell the embryos with a good price. The problem is they need equipment and skills for ultrasound and ovum pickup. They need local anesthesia and train the cows. How about when the cows get pregnant? There are some papers that showing that they can do transvaginal ovum pickup up to 3 months pregnancy. Means the fetus hasn't big enough and the operator can grab the ovaries through the rectum. The seasonal breeding, yes, become an issue in animal living in a subtropical area, but I assume it shouldn't be a problem if we do it in Indonesia, because as I mentioned earlier, we don't have any breeding season in Indonesia. So there are few papers about this transvaginal ovum pickup. It is non-invasive recover from untransferable from live animals, first developed in human as a service for IVF. And in 1987, they developed ultrasound-guided follicle aspiration. And that's the, if we got the copy, then we can click on this reference. So together with in vitro fertilization of the egg after we do collection, it is flexible, repeatable, and produce embryo from any given live donors. Some good cows can be live donors instead of we milk them. We can use them for donors. So it doesn't interfere with the normal reproduction. Like if you go like multiple ovulation embryo transfer, then we have to stimulate the cattle, let the cattle come into heat, then we inseminate the cattle so the embryo is growing and we flush. That's why this multiple ovulation embryo transfer is interfere with normal reproduction activity. While ovum pickup, they don't. It doesn't interfere because we can do it anytime up to 3 months of pregnancy. So the cows can bear their pregnancy, and after 3 months, we not do any more ovum pickup. So any female start from 6 months old until the 3rd month of pregnancy, on soon after calving, can be used as a donor. So no, this one being more and more used and more commercial. There's a company in Brazil, they call it Brio Embryo. Their website showing that they've been doing this one for years, and they produce hundreds of cattle embryo from any breeds, including the tropical breeds. So if you look at this one, it looks like if we're having issue with embryo, in vitro embryo production using abattoir derived from abattoir ovaries, then this transvaginal ovum pickup can be used as another alternative.
Excuse me,
So-
Dr. Mulyoto. You have 5 minutes remain for the
Okay, this
presentation.
is the last one. So there are factors affecting the ovum pickup. If you saw more follicles, they got more oocyte. It's influenced by the breed, nutritional status, and the climate condition. Somehow, Indonesia is very lucky because most cattle in Indonesia are post-indicus. And we found out that post-indicus produce more oocyte and compared to post-taurus. So currently, Brazil is the top list of embryo production, and the heat stress might affect, but it's not really significant. I mean, not big, and the temperature supply on follicles formations and everything, but if we look at the post Indicus is the best cattle, means it's not much concern for Indonesian climates. Yep. So some technique need to remove the dominant follicles just to help the developing of many more ovaries. There is individual variation like age, reproductive phase, response. Some hormonal stimulation it might require, might not. And there's another story from Japanese black cattle or Wagyu. There's a YouTube link towards that one, but I'm gonna apply it now because it takes quite long. And this how we run the ovum pickup. One is we need to look at the anesthesia. Usually epidural is enough. And then this the probe for ultrasound probe, which is covered. It will be covered by gel and then inserted into the vagina. So if you look at that one, then you can see the probe going to the vagina, and then the other hand going through the rectum, grabbing the ovaries. So this the same thing, and then later on when we can grab the ovaries, we're going to put the needle on this area. The aspiration needle will go in because we need to aspirate the liquid from the follicles. So through the ultrasound screen, we can see where is the follicle, what that looks like. Then you can see this the needle. And we keep doing this work while we're watching on the screen. So I'd like to show you that we got this equipment in Indonesia. It's not working. Okay, I'll skip this one. I'll show you later. So by seeing what's in Indonesia, the Undang-Undang Nomor 18. So Indonesia should go to transvaginal ovum pickup if we really want to develop in vitro embryo production. So this is the opportunity of Indonesia because located in the equator. So there's no variation in photo period. There's no breeding season. So if we can manage well, so we can have few cows every month for as a donor. The food, animal forage and animal feed relative available. And this one, even though it is still lower, but it's more on technical rather than the cattle or the weather itself. So I would like to thanks to the organizing committee, my team in EPRD, Monash University, and colleagues and team in Advanced Production in ICAHLS, Victoria. Before I finish, I will to play one of the video that I hope you recognize what's on the screen. So this technique is, there's Dr. Erma from Airlangga been doing this one. The only difference is the probe for standard assessment. So this ultrasound, so we need just change the probe to the other probe that get better transducing facility, so they can look at the follicles and having the needles connected to that one. Yeah. So that's about the facility we got in Indonesia. So I will say we do have the facility, we have the equipment, we have the skills. What we need just to do it in Indonesia. Thank you. Selamat siang.
Thank you, Dr. Mulyana Pangestu, for the very interesting lecture. And now I would like to open a question for the discussion. If any of participant have some question, you can ask your question directly using the raise hand feature, or maybe type your question on chat box.
For the speaker, do you prefer answer each question one by one or after all collected questions, Mr. Mulyana?
It's really depend on the time they allocated for everyone.
Okay,
Yeah.
we do it.
Okay.
I'm happy to answer now or later.
Okay.
So please, any questions from
Please,
now?
any question from the attendee?
I'm happy to take question in Indonesia.
Yeah, you can ask your question in Indonesia and I will help to translate. It's okay.
Okay, maybe the committee will help us to collect the questions. Okay, to open this session, maybe can I ask something, Dr. Mulyana?
Please.
Okay, thank you. I'm glad that you understand about our situation in Indonesia, about our legal standing, about our social issue, about this reproduction in Indonesia. So you mentioned that this technology, in vitro fertilization or ovum collecting in abattoir is restricted because we lack of opportunity in abattoir because it's prohibited to slaughter the cattle female productive in Indonesia. But I think this technology is a breakthrough about this situation because if someone or if the farmer send the productive female in slaughterhouse, the police or the government will punish the farmer. But this technology will be the breakthrough when the farmer is in some condition send the cattle to the abattoir. So what do you think about this technology to practice in abattoir when the farmer send somehow and somewhat to the abattoir this cattle, this productive female?
Thanks for the question. It's a very interesting question because we know there's always problem in Indonesian farmers. They say they need money to look after their family, that they have to sell or slaughter their cows. But on the other hand, government says, no, if you sell the cows, then you lose the opportunity to increase the population of the cattle in Indonesia.
Yeah.
So it's quite clear that it's up to the government whether they can run like a buyback system from the farmers. If the farmers wants to sell their cows, then either the abattoir itself should let the authority to stop them from doing this one.
Yeah.
Because I understand that the farmers themselves never bring the animal to abattoir, but the middleman who bought the cattle from the market, the one that bring it to the abattoir. So actually we can detect what's happened when the farmers tend to sell their cows. So in this situation, whoever the authorities working in the cattle market should be able to prevent or stop them without making a difficult condition for the farmers. For instance, if we know that there's a farmers from this village want to sell their cows, so this, if the government really wants to taking care of that one, so the government should either buy that cattle from the farmers, or any other government institution or NGO should buy that one. Then we can pull those cattle in an area, so we can use that cattle. If the cattle is from good genetic cattle, we can use those cattle as a source of offering. So like in Surabaya itself, I know there's no cattle market in Surabaya, but staff from Airlangga University can go to any area like Probolinggo or another area in East Java to help to prevent this cattle slaughtering without the farmers losing their income.
Yes, so it's our rules, it's our positions to solve this problem. I think that the breakthrough. So any questions from the participants?
Yeah, I think we have 3 questions. But the question is in Indonesia. I will try to translate the question maybe for the international attendee. What is the benefit or the advantage and the disadvantages about the oocyte aspiration from ovarium from the abattoir compared to the transvaginal ovum pickup in Indonesian condition?
Yeah. Okay, I got 3 questions here from Dr. Chuk,
yeah.
Imam Restiadi. Yeah, the advantage and disadvantage. I know I've been working for abattoir in abattoir for many years. The problem with abattoir, we do not know the background of those cattle. How's the cattle, where the cattle coming from, and then how the farmers feed the cattle. I mean, it sounds very sad because like in Australia, if you got like in the drought season and we got the cows from Queensland, so most of the time the quality of the oocytes are really bad because they've been compromised with low food quality and everything. So I will say that we need to have at least like 200 ovaries, I mean from 100 cows, to produce probably around good 500 blastocysts, which is very low. The efficiency probably less than 10%. Sorry, 500 embryo and then end up with probably 200, 300 blastocysts. So the efficiency very low and very labor intensive. However, if we use, we collect the oocyte from a live animal, then we know how's the animal condition, health status, feeding and everything. So the quality of the oocytes a lot better than, I mean, not saying a lot better, I mean, we know what we're gonna get from the live animal. So from my experience, if I do collection from 100, 200 ovaries, then getting that much. So maybe if I collect from the live donors, I just need probably only 10 live donors to get the same amount of blastocysts. So the second one, the ultrasound can be replaced ultrasound with something else. Unfortunately, we cannot replace it with any other equipment because what we need is to see when the needle going into the follicle in the ovaries. Otherwise, we blind. So yeah, unfortunately, we need the ultrasound, and ultrasound is not something that very sophisticated. The simplest one, I can see like my team use a very old second-hand, maybe third-hand ultrasound. We buy it for about $200 as long as we got the good probe. Then that probe can be connected with the needle. Then we can get the ovaries out from the oocyte out from the ovaries. Before we doing OPU, any special requirement? What we need is healthy cows as a donor. I mean, healthy, not sick, and a good nutrition status. So the egg that we got from that cows is a good quality. Also, the number of follicles. There are some issue with the breeding season or anything, but with Indonesian condition, we can just ignore it because we don't have any breeding season in Indonesia. Okay, terus.
Okay, excuse me, Dr. Mulyoto.
Yeah.
We still have 2 more questions, but I've been told by the committee that we are running out of time. I'm sorry. So
it's okay.
That is the question for today.
Thank you for all the question, and I appreciate for the presentation and the question from the other participants.
Okay, but before we end the session, I will read the brief summary from this lecture. So Indonesia is a tropical area. Actually, that is a big advantages for us from the reproductive perspective. But unlike Indonesia, in subtropical country, the animal has specific time for the reproduction time, and to alter this breeding season, human intervention is needed, and it is quite common in some countries. Some of the reproductive technology used is artificial insemination and embryo transfer, but embryo transfer is much more common because today, because it is give the male and the female efficiency. And in vitro embryo production from the abattoir that we do the oocyte from the abattoir is a common practice in some countries, but in Indonesia we have some problem to apply this technology because slaughter productive cow can be illegal according to the Indonesian law, and it is almost impossible to practice the abattoir through oocyte. Okay, maybe that is all what we can sum up about this lecture. And again, I would like to express our gratitude for Dr. Mulyoto Pangestu, Master of Reproduction, PhD, for sharing your time and expertise with us. And as a token of appreciation, I would like to present this certificate. Okay, thank you, Doctor. And ladies and gentlemen, we have had all the presentation for this session. Thus, we may end this first plenary session. Thank you very much for your participation. And I will hand over the time to the Master of Ceremony again.
Thank you very much to Dr. Bilkis and Dr. Mirza for leading this session. And I would like to say thank you too to Dr. Syamsul Ma'arif and Dr. Mulyoto Pangestu for the amazing presentation. Ladies and gentlemen, now we move to the plenary session 2 and plenary session 3. In this session, we'll be guided by our moderators, Dr. Lina Susanti and Dr. Hartanto M. Raharjo. To the moderators, the time is yours.
Thank you, Master of the Ceremony. Ladies and gentlemen, for our second plenary session, Joining us from Seoul, South Korea, Professor Gujang, DVM, PhD. 네, 안녕하십니까 교수님.
Hello, thank you. Wow, you can speak Korean very well.
아, 네, 저
Can you hear me?
서울대 다녀왔습니다.
Oh, really? Yes.
네.
Good morning,
It was nice
Professor.
meeting you.
It's a
Good
pleasure
morning.
to have you to joining in this occasion today.
Yes.
Ladies and gentlemen, Professor Gujang, DVM PhD, will talk about precision breeding on improving cattle traits.
Okay, but before we listen to the presentation, we would briefly introduce Professor Gujang, DVM, PhD. So, Professor Gujang obtained his PhD in 2006 in the theriogenology and biotechnology from the Graduate School of Seoul National University, Republic of Korea. From 2008 until 2012, he became the assistant professor in the same department, and in the next 5 years, he went on to become the associate professor in the Department of Theriogenology, Seoul National University. He was the visiting scholar in IMBA, Vienna, Austria in 2018, and he is now the professor in the Department of the Theriogenology, College of Veterinary Medicine, Seoul National University. His research area is the theriogenology, and Professor Gujang has 129 papers indexed in Scopus and a whopping 2,827 citations recorded in Scopus. And his age index is 28.
Thank you.
Professor Gu, the time is yours.
Okay, thank you. Thank you for invitation. Can you hear me everything?
Yes.
Okay, yeah, I'm very happy to introduce the progress in the academic area. I'm hope to also see you guys the next again. I will sharing the monitor. Just wait a moment. So today I will talking about the precision breeding in improving the cattle trait. I will do a lot of data, but I have to do only limited time. I'm just provided only selective data in here. So some of the guy here, list audience, maybe you don't have enough background in the theriogenology. It will be a little bit hard, but I hope I will try to explanation with the very easy and very slowly. One thing, the previous, I forgot the name, Dr. Monas from university. He was well introduced about the general background in vitro production embryo. So firstly, I hope everybody heard about the genome editing, including the CRISPR-Cas9. Around 10 years ago, zinc finger nuclease is the first generation of the genome editing. That kind of the genome editing technology will be applied in a lot of the field. For example, the human disease therapy, new drug screening, on the agriculture and cell animal model. So still, nowadays, all over the world, many lovely many scientists working with the genome editing technology. In like you and me, we are veterinary science. The field is limitedly genome editing technology will be applied to kind of the big challenge in the new trait, like the horniest cattle, and then resistant to PRRS disease. This is the two outstanding result came out almost 6 years ago. UC Davis group, they will be reported about the design precision breeding to make the hornless cattle. And then same, the Crenshaw University, University of Missouri, they will be reporting about the super pig. It means that the pig resistant to infection of PRRS. Maybe everybody well known that how damage big is the PRRS1. So I'm just briefly mentioned about in cattle field. Everybody well known that cattle is the 20,000 years ago around. There will be cattle and wild cattle was to do the domestication, and human we did the artificial selection and crossbreeding, and then we starting the recorded the base genetic selection, and then around 1997 around there in science developing the sperm technology and embryo technology. We called this one assisted reproductive technologies. Those kind of the technology include the semen freezing, insemination, in vitro fertilization, multiple ovulation, embryo transfer, sexing kind of tools. Another one, the nuclear transfer, was developing to making the same genetic copy. And based on the nuclear transfer, many stem cell biologists, they will be made the induced pluripotent stem cell. This is the nowadays another huge scientific field to clinical application. And then recently, we some scientists developing the already mentioned about genome editing. So this one, and then this one technology will apply to the cattle to make the special trait based on the several techniques: quantitative trait, marker assist selection, genome selection, a lot of the molecular biologic tools, transcriptome, proteomics, epigenetics, many omics data was supporting the making the genome editing breed. Historically, again, go back to how big challenge in artificial assisted reproductive technology. This is captured from the USAID, from the United States. Take a look at this one. Look at the picture. The 1940, at that time, one cow generated and produced the milk per cow, milk 2,000 around a kilogram. But nowadays, 2010 is the milk production was increased per cow around the 10,000 milk. However, the number of the cow is gradually decreased because those year was the big challenge. It means the artificial assisted reproductive technology applied to here. So, firstly, is the initial stage in the cattle domestication. Many farmer and scientists, they did the phenotype-based natural breeding. It means only selecting the apparently looks good, means the female one and male one. And we just did the breeding by natural breeding program. So we gotta do next generation. This is still some of the area, very limited. The farmer, they're gonna use still this very classical breeding program, but that have the disadvantage means the very ineffective breeding program because the cattle has the single pregnancy, long gestation. It needed a lot of money to improving the genetic trait. And then after developing the sperm freezing technology, scientists developing the new service, artificial insemination. Everybody well known that. AI, big impact in the cow industry because we only selecting the donor, means the super male, and extracted the semen and inseminated the female. So AI accelerating, improving the cow breeding program. And then nowadays, all over the country, the AI spread all over the farm. Even more, some of them, based on the superovulation program and estrus synchronization program, recently they do some time fixed insemination, not estrus detection. Usually still many farmer or some technician, based on the estrus detection, they did artificial insemination. But nowadays, in advanced country, we doing just the time fixed the insemination without any detection of estrus behavior. Just index the time, we just inseminate sperm. Look at this, the increasing of the time fixed artificial insemination. Nowadays, it's very highly improved there. Another program is the multiple ovulation and embryo transfer breeding program. In previous session, Dr. Moyulta, he was mentioned about this kind of one, multiple ovulation. So this one is the two selection. One is the female donor, the other one male donor. Female donor was treated in the little bit complicated the hormone treatment. After that, multiple ovulated was induced, and then the super male was inseminated. The high skilled technique is needed to collect the embryo, and those in vivo embryo transfer the recipient. It was the successful rate is high. So this one, multiple ovulation embryo transfer, have the pros and cons. Pros is a high pregnancy because its embryo was grown up in vivo. That will be highly contribute in improving genetic trait in all of the world. Still, this MOET, multiple ovulation embryo transfer, very actively working in all of the world, but it have the cons, like the higher skilled require embryo collection, high cost for treatment. And then there will be application times going on that production of the in vivo embryo slowly gradually decreased nowadays. Because previously already mentioned about from the Monash University, application of the OPU based the embryo transfer program. Is it everything the same with the multiple ovulation embryo transfer? But one thing is the different one. Only embryo production was the in vitro, not in vivo. So two oocytes originated from, one is the slaughterhouse, the other is the ovum pickup. And then male sperm already established all over the country from the proved the bulls, and we did the in vitro fertilization and well grown up the blastocyst and transfer the recipient. OPU have pros and cons. Pros is nowadays, previously means the 2010, for 2010, there will be limitation to low, in terms of the low pregnancy. But after changing the cultured media, high pregnancy level, and then consistent embryonic development. And this one also, like the multiple ovulation embryo transfer, contribute to the improving genetic trait. OPO have also as well cons, low pregnancy before the 2010, but nowadays mostly improved that. But still there are many laboratory, many country, underdeveloped country, they need technical improvement. PONS is the highest skill required for embryonic techniques. I will do summarizing the in vivo versus in vitro. This is I already mentioned about in vivo embryo production gradually increased 2020. And however, OPU embryo was the increased like that. Take a look at the recent, very recent 2020 data. It was the 3.4 twice. It's a high yield in OPU-based embryo production. Is applicable in many countries. This data was mining from International Embryo Transfer Society newsletter. If you wanna do more data, you can join the ITS and then download the newsletter PDF file. There will be every year provided the in vitro and in vivo embryo production record. Right, everybody agree? Compared to other species, livestock species, cattle have the long gestation interval, low fecundity, with slow genetic progress. So we need the improving the technology to make the improving the traded based on the precision breeding program. This is I'm suggesting some future breeding program with genetically engineered tools. This is the basic current program, donor selection, male and female, and then some of them still they working with the in vivo embryo. It called MOE, multiple ovulation embryo transfer. The other one is the OPU, based in vitro produced embryo, and then highly viable embryo was collecting the two systems. This one embryo was the transferred recipient. And then this pregnancy, and we get the elite calf. And then this one is the raised in the farm. And many scientists and farmer, they will be selecting based on the phenotype and good phenotype and genotype, genome selection. Again, this derived the calf were again employed to the donor selection, and then again to female male donor was provided the elite embryos. Another one we're gonna apply to some genetically engineered tool. For example, we isolating the primary cell from tissue, the elite cow calf, and culture the tissue again to make the genetically engineered tool, communicated genome selection tool. It means the specific SMP, single nucleotide morphism based. We can making the high level of the high yield of the milk and high quantity of the meat. Another one is this genome selected tools was combined mentioned about previously genome editing kind of the CRISPR-Cas9, and then we can making the design. It means the precision breeding. We can make it. So what I am doing currently, I was around the 20 years history in my life science in cattle with cattle. Usually when I was young means when I was the master degree and the PhD degree. At that time, my collaborator, we applied to at that time, everybody well known in the MOE system is population. That will be very interesting to me at that time because I am the trainer. So I was very happy to get the in vivo embryo and transfer the recipient. We got a lot of the in vivo derived the calf. That calf grown up and then contribute to the field. After that, I was developing the in vitro fertilization technique. So my colleague, we're gonna make some special media. It's a chemically defined one. nowadays many countries, even the UK, USA, and Australia, they provide sales some chemically defined one. But in my laboratory, we developing the special chemically defined media. You're gonna see the more specific component in the media. You can download this annual generative article we published about that comparison one. And then this is the original paper about improved in vitro embryo development, increase the efficiency producing viable capsule using defined media. At that time, we firstly made the homemade culture media without FBS. The cultured embryo without FBS was grown up, and then after freezing and sewing, high survival rate was observed. Sorry. Take a look at this video. This is the time-lapse embryo culture without FBS. Take a look at the IVF embryo grown up to blastocyst, even the hatched blastocyst. Most of the embryo growing up well. Take a look at this, the very beautiful developing of the bovine embryo. This is the after embryo freezing and sewing. Our protocol is well established. The sewed embryo was survived in vitro. Most of the over than 90% embryo survive. It means our freezing system is very stable and supporting the good embryonic development. And then my interesting scientific interest moved to the genetically engineered tool area. So 2006, my colleague, we together generating based on the DNA delivery system into cattle, we successfully generating the transgenic cattle, female and male. And we find out with some fluorescence microscope, we can see well expressed the fluorescence protein in the cell level. Very last month, we sacrificed the one GFP transgenic cattle, and then we isolating a lot of the organs, the heart, kidney, liver, lung, testis. Take a look at this, all the organ expressed well with the any silence. Interesting, look at this one this is the testis. Everybody well known the anatomic name. This is the epididymis area. Take a look at all epididymis of the cell. It strongly expressed the GFP. It means transgenic cattle transmitted their transgene into the next generation. So I'm summarized my transgenic cattle study. 2060, at that time, we just published the paper about transposon-based the transgenic cattle system, and then analyzing the whole genome sequencing to identify the transgene where was the integrated that. And based on that study, we keep going one more study. The first generation one, female and male, we did the natural breeding. We find out the next generation. That generation was employed for NGS sequencing, whole genome sequencing, to identify there is any genome instability. There will be interestingly, there is no any genome instability issue. There will be that family, the male and family son is growing well up currently. We published 2018 in BMC Genomics. If you interested about data, You can download the paper. And then 2010, 20, we again more the application of the transgenic cattle. We isolating the cell line next from the F1, and another one we generating another F1. We delivering the one. Using the based on that, we applying the CRISPR-Cas9 system to enrichment the knockout efficiency. Take a look at this one, the GFP positive and GFP negative. We simultaneously transfect the two guide RNA. One is the for GFP, the other is target locus. The both of the GFP knockout cell line, it means the cell will be susceptible to transfection. It means the target locus another guide RNA working well. So we find out the highly efficient knockout cell line in bovine system. And then based on this very strong evidence, we apply to jump to the genome editing to make the real precision breeding. So firstly, we isolate, previously we published about some two papers based on the in vitro one. First one, pig porcine fibroblast to efficient genome editing. And another one, prion gene, mad cow disease mutation in the bovine cell level. And basic the accumulation of these data. Finally, we published about the real cattle CRISPR-Cas9 technology. This is the basic concept. We designing the single guide RNA to exon 2 domain, and we injecting the microRNA after in vitro fertilization. We injecting the Cas9 RNA, Cas9 for guide RNA for myostatin, MST gene, and then mutated embryo was transferred to the recipient. Finally, we generating the MSTN mutated the cap in 1 month and 2 months. Take a look at this, the outgrowing muscle in the skeletal muscle area. And now it's 25 years old. Take a look at this one well-grown muscle in the area. So with practical level, we generating the precision, the breeding. And then the last
Excuse me,
one.
Professor, you have 4 more minutes left.
Okay, almost finished. Okay, this is 25 years old. We have the male one. So we monitoring the germline transmission. This mutated one generated the next generation. The female, we did ovum pickup to oocyte, and we collecting the semen and IVF, and we find out the mutation embryo and transfer the recipient. We find out some next generation. Another one, the knockout semen was fertilized to the wild type oocyte and electroporated the guide RNA. Another one, prion disease. We find out the double mutation one. So, and we also biopsy the muscle. The muscle fiber is significantly is thin, and we also isolating the myoblast from the knockout one. Take a look at this, the well-grown up and differentiated muscle fiber in vitro. And take a look at this, the efficient embryo development and genotyping. Finally, we got one cap 2 months ago. And then what's the genotyping? It's the same one with the founder animal. Ongoing project, we have the still project is a prion knockout one, and it's the 24 months old. We are isolating a lot of sperm, improving the unique nitrogen. The in vitro fertilization, we find out almost 99% knockout embryo. And another one, recently we also generating a double knockout. One is the beta-lactoglobulin, one is the myostatin. We have the 3 double knockout cattle. They will be grown up well. Currently, their age is 6 months old. Maybe next year, I will be present again this updated data. Another one, we have some special Cas9 model. This Cas9 ubiquitous expression all of tissue, we can make easily generating the knockout and knock-in embryo. Another one, this is the kind of the in vitro laboratory work. Is we are applying the rat project. I have my colleague, we have the special breeding center in close to Seoul, not close, it takes 2 hours. We're developing the precision breeding center. So we are collecting the superior phenotype and inferior phenotype. We did starting the genome sequencing analyzing to comparison and considerable genome editing developing phenotype. This is our facility, representative picture. We can do the OBM pickup at that time, the pole, the stool, and here we have the very close area OBM pickup culture. This is the OBM pickup representative oocyte. Every time, skilled the technician and veterinarian, once OPU, we can get over than 10 immature oocyte. So in the future, probably I will do summarizing. This is the capturing the other paper. It's a long time ago, and the livestock was the dominant factor is invariable, and then the human was intervene, and then human was selecting the phenotype based using the artificial selection, and nowadays the human was to make some technology genome edit one. It will be some make the designing the breeding system. So maybe within 10 years, I probably in many countries, genome editing technology will be spread for genome editing one for productivity, disease resistance, and some the basic science. In many countries already the approved the gene edited cattle for food use, such as the Australia and the Brazil and Japan and Paraguay. Many countries they will be starting the approved the genome edited the individual for food consumption. So thank you for your attention. This is my laboratory one, and then I was joined together company. So my colleague there, a lot of my supportive the company, the Seoul Milk Corporation. The company was the number highest the dairy corporation in Korea, and then pig the corporation and genome editing one, basic science one. If you have any question and collaboration, feel free to contact my email. Thank you for your attention. I will be happy to question.
Okay, thank you, Professor, for a very insightful talk and such an advanced applications of genomic science.
Ladies and gentlemen, we have 5 minutes for discussion. Hand feature in your Zoom if you have any question.
You could also type your questions in the question box and we would read them to Professor Gu so he can answer it.
In the chat box, I find some
Questions?
question.
Yes.
Do genetically modified livestock have the trait that inherited well by their offspring? Yes, we find out the well transmitted the next generation. We'll keep going to more number of the application. Every gene edited cattle, it means the traded transmit to the next generation. I will be next year. I will be happy to publication my scientific analysis. If you update or monitoring my scientific activity, you can find out the answer again.
Okay, that was really interesting. Okay, so if anybody has another questions. Okay, so there are 2 other questions in the chat box.
Two question. I didn't see.
Okay.
For my, I'm Erica Martining, Orlando University. This is not. This is for question for me or not? I don't know. This is kind of the some government or yes. This my research. Some of them supporting the government. A little bit. Some more also supporting the company. The mostly I was initiated my research was supporting the Korean government.
Okay, thank you, Professor.
How long it does it take to do the research? It's to take a long time. Everybody will know that because the long gestation. My project was starting the 15 years old. So still keep going. During the research and difficult, how do research solve this problem? Yes, a lot of difficult because sometimes I in the FMD issue, foot and mouth disease issue in Korea. So the research farm was isolating. I cannot go enter the farm. Also another one, the embryo was contaminated. Also some of the calf was died from the diarrhea like that. A lot of the animal health issue it's larger. It will be enough to the answer. Erica Martini.
Okay, Ms. Rika, is the answer satisfy you? Okay, probably yes. Okay, so I think that's all for the discussion session. As the professor said earlier, if anyone has another question or just another thing to ask for the professor, you could reach Professor Gujang by his email. And thank you for a wonderful discussion.
Thank you. I hope to see you the in-person meeting. I want to visit the Indonesia.
Oh.
Bye-bye.
Yes, we would be. But before that, Professor, just as a symbol of our appreciation, we would like to present you the certificate from the committee. 감사합니다, 교수님.
감사합니다. Thank you for
Thank you so
attention.
much.
Everybody welcome in the future.
Yes, we would like to invite you sometimes in the future.
Okay.
Okay, 감사합니다.
Bye.
Okay, so now for our third plenary sessions from the University of Sydney, Australia, Professor Simon de Graaf, PhD. Okay, so we will just introduce briefly about Professor Simon de Graaf.
Okay, so Professor Simon de Graaf is a lecturer from 2007 until 2008 in veterinary basic sciences at the Royal Veterinary College in London. And then until now, he is a permanent academic position at the University of Sydney, teaching in the Faculty of Veterinary Science and the School of Life and Environmental Science Faculty of Science. And from 2010 until 2020, he is a vice president and executive director of the Association for Applied Animal Andrology. And in 2014 until 2015 and 2019, he is a visiting scientist at the Station de Physiologie de la Reproduction at des Comportements Institut National de la Recherche Agronomique in Noisy, France. And until now, he is a Secretary General of the International Congress on Animal Reproduction. His research area is animal reproduction. He has 72 papers Scopus Index and more than 1,000 citation Scopus recorded and have 24 AIDS Index.
Okay, so Professor Simon de Graaf will be presenting about artificial breeding of sheep. And so without further ado, ladies and gentlemen, we present you the lecture by Professor Simon de Graaf.
Well, hi, everybody. It is an absolute pleasure to be with you here today. I'm terribly sorry I can't be with you there in person, and sorry as well that I'm unable to join you live so that we could have some discussion at the end of this presentation. But not to worry, we'll do our best and we will attempt to make this, or I will attempt to make this presentation as engaging and informative as possible. So hopefully you all do get something out of it. So as I've no doubt already has been announced, this presentation is about the future of sheep artificial breeding. There's going to be an obvious Australian context, but there will also be a little bit of discussion during the course of the presentation about how this is linked to matters in a global sense as well. So to begin with, we'll chat a little bit about the current status of sheep artificial breeding. Then we'll move on to some of the threats that this particular part of the artificial breeding world faces, what we face in this species, and the same could be said for goats as well. And then I want to talk to you about some of the solutions that we have been working on here in my laboratory at the University of Sydney to address some of the problems, some of these threats that have been identified. So to begin with, current status of sheep artificial breeding, as I said. Well, this particular slide is a little bit confronting for some people because they think, what on earth are these sheep doing upside down? Now, I imagine that much of the audience will know what's going on here, but for those that don't, this is how you conduct artificial insemination of sheep when you need to use frozen semen or when they have been superovulated. And we'll get into some of the reasons for why this is in a minute. But basically, this technology is known as laparoscopic intrauterine AI. It was developed in the early 80s in Australia. And from that point in time, it ended up going all the way around the world. It's the only way in which you can get frozen semen to have high enough fertility. Reason being that the cervix is a very distinct barrier in the sheep. You can't pass a catheter through it. The frozen semen can't get past, the frozen sperm rather can't get past, and so fertility is impaired. We'll take a look at a slide on that soon, but basically when we talk about artificial breeding of sheep, we predominantly mean this technology. Beyond intrauterine AI, we also mean multiple ovulation embryo transfer. So, of course, this is where we have superovulated a donor female, and you can see an image there of an ovary which has been superovulated. She's got a number of corpora lutea there, and then you're able to collect embryos, or hopefully collect embryos after you have inseminated that animal using the technique that you see these two gentlemen here demonstrating. And so long as fertilization is good of all of those eggs, you will end up with all these embryos. You flush them out around about day 6, and then you transfer them into synchronized recipients. And around about 60% of those embryos should, we call it stick. We say those embryos should stick, or the stick rate of the embryos should be around about 60%. There's another technology which is used very, very tiny amounts here in Australia and probably even less globally, and that's GIVIT. So this is juvenile in vitro embryo transfer. You can superstimulate lambs as young as 2 or 3 weeks old and get quite enormous ovaries, as you can see there, big ovarian reserve. And you can aspirate those follicles, take those eggs, do IVM on the eggs, do IVF, end up with embryos, end up with blasts, and then do transfers on those. But look, it's a very involved technology, not used very widely because the levels of success aren't particularly high. Nonetheless, these are really the 3 things that we talk about when we really discuss artificial breeding of sheep. There are other subcomponents. You think sex sperm, think about the synchronization which happens and whatever. We'll get into how some of those things integrate in a moment. Now, you notice that I mentioned cervical AI. Well, this is what cervical AI is. So this is Dr. Stephen Salomon, who was an academic here in the 60s, 70s, and early 80s, and he developed semen freezing in sheep and also this cervical AI method. So this is where you introduce semen directly into the cervical os. It's quite effective if you have fresh semen, but as I mentioned, with frozen semen, it doesn't work very well. And you've only got to look at that table there to see what's going on. So fresh or frozen semen was inseminated at quite high numbers into the cervical os in this particular experiment in 1970. And you can see that the fresh sperm really do populate that cervix and then I can tell you migrate through the cervix in much higher numbers than the frozen sperm. Now, that's even with the frozen sperm exhibiting quite high forward progressive motility, quite high viability. They seem to be fairly normal in the way that they behave, but they just are unable to penetrate that cervix in particularly high levels. So as a result, in the early 80s, this laparoscopic AI was developed, and you can see from some of the research there by Chiz Maxwell, who was one of the gentlemen in the picture there. If you compare these different insemination techniques with the same number of frozen thawed sperm, vaginal AI, cervical AI, they result in very low pregnancy rates. But for intrauterine AI, when you bypass that cervix, you end up with quite a high level of fertility. And that is something which was obviously of great interest to the people that were trying to utilize frozen semen, and is why very rapidly this was taken up by the international industry. Now, to get a little bit of a snapshot of just how much artificial breeding occurs in Australia, this data is getting a little bit old now. It's from 2016. But we surveyed the sheep artificial breeding companies in Australia. You can see a Google map here of all of the different companies in Australia that do service the sheep industry. If you're interested in looking at that further, you can find it on my website, simondegraaf.com, in the blog posts. But after surveying all of these companies, we found that there's around about 250,000 artificial inseminations which are done each year in Australia. And of these, around 7,000 donors are flushed per annum. So certainly numbers that are much smaller than the number of AIs which are done in Europe, although in Europe it's cervical or paracervical artificial insemination rather than laparoscopic AI. I'd say South Africa is probably the only other country which comes close to the same number of laparoscopic artificial inseminations in sheep as Australia. But what's interesting is that sheep lag far behind all other agricultural species in terms of the amount of the percentage of females which are bred to artificial insemination. Now, in Australia, these numbers for Australia, we see in dairy cattle around 84% of females are bred to AI. Breeding sows, it's up at about 70% of females. Turkey hens was an interesting one. They're all bred to AI because they've had so much genetic selection for breast size that they're just unable anymore to be able to mate naturally. So they have to undergo artificial insemination. Even humans, which obviously is not an agricultural species, but it's an interesting observation. there's now 17% of women who do undergo some sort of artificial, what we call it, assisted reproduction in humans, as opposed to sheep, where it's way down at 1%, very, very low. Now, some more background information, the scene of the current status of artificial breeding in sheep. I want to just touch on how sheep are synchronized for artificial insemination and embryo transfer. So, of course, this is a key part of the artificial breeding process. Artificial insemination and embryo transfer is done by highly trained technicians or veterinarians, and they can't stick around on farm for the whole 17 days of the estrus cycle, just waiting for animals to come into heat. They have to have their animals synchronized so that they can all be inseminated on a particular day. So the main way in which this is done is a 12-day administration of an intravaginal pessary. Now, it can be, comes in two main forms. In Australia, it only comes in one form now, the cedar, or in Europe and various other parts of the world, you can get sponges as well, which is the first type of intravaginal pessary. But basically, these have a progestogen in them, and it artificially extends the luteal phase of the ewe. When you withdraw the cedar or sponge, you give 400 units of equine chorionic gonadotrophin. So that is a substance which is obtained from pregnant mares. Indeed, it used to be called pregnant mare serum gonadotrophin. And this has mainly FSH-like effects. And so it gives those ovaries a little bit of a tickle, increases ovulation a little bit, but it also just allows those animals, particularly in the non-breeding season or at the start of the breeding season, if necessary, to be synchronized to initiate that next follicular wave, which you can see here. So there you've seen on the screen a representation of what happens when we administer our progestogen. You are artificially extending that luteal phase so that you don't have the follicular phase just start when it would normally. But when you withdraw all of those intravaginal pessaries at the same time, then all of the animals will start to cycle again at the same time, and you will get estrus and ovulation occurring. So that ovulation will occur with if they've been synchronized with cedars around about 55 hours after the cedars have been removed. And so laparoscopic AI, well, it says on the packet to start about 48 hours after they have been pulled. Most AI companies will try and push that a little bit later, so sort of like 51 hours and onwards. But nonetheless, that is the means by which all of the assisted reproduction is sort of underpinned by these particular synchronization programs. If you are doing a MOAT program, so this is in a superovulated donor, you obviously need to give some follicle stimulating hormone. So Foltropin V is the particular product which is on the market these days for sheep. And what that does is at the end, basically you give that multiple injections of that at the end of the period in which the cedar has been implanted, and that increases the amount of recruitment and selection of developing follicles, and means that instead of having one or maybe two follicles developing, you will have many follicles developing. So it can be up to sort of 20, I mean, sometimes even more. You don't want too great a response because you potentially end up with poorer egg quality. But nonetheless, this is what is happening for those artificial breeding programs. Why am I telling you all this? So it's not just trying to take you back to university. It's because some of these products have certain issues associated with them. The ECG has been particularly difficult to come by in recent years, and there have been increasing ethical concerns around its use. And follicle-stimulating hormone, it's a product from pigs. It's from pig pituitaries, and that has some issues as well. So these are all things which you need to know in order for you to understand the next part of the presentation. Thought you might like to just review some of the changes that have occurred since the early 80s when this technology, particularly laparoscopic AI, was first developed. So in AI, we've seen sponges replaced by seeders. Believe it or not, back in the day, there was very little, if any, sedation or analgesia. That's certainly changed now. We've gone from using pelleted semen to semen straws, although still a lot of semen pellets used in Australia. The whole procedure is much faster, but overall, pretty similar technique. Equipment's basically the same, and the actual programming of the use, the hormonal programming of the use is largely identical. The ET, pretty much same as above. Now they use Foley catheters to flush. That's antegrade flushing of the uterus rather than retrograde flushing. And, this porcine FSH is used rather than very, very big doses of ECG, which certainly work to a certain extent, would cause superovulation, but you get these premature luteinized follicles, which caused issues with egg quality and ongoing issues for the animals. So that is something which has been an improvement. As for the future, well, we will see. Now here, let's just shift gears a little bit now that we know kind of where sheep artificial breeding is in Australia particularly, but globally it's basically at the same spot, just smaller. What are some of the threats? Well, we don't have a surgical alternative, or a non-surgical alternative, I suppose that should say, to AI frozen semen. So if you want to use frozen semen, you have to use laparoscopic AI. You saw it in those graphs at the beginning. You get very poor results if you just put it directly into the cervix or into the vagina. So that's an issue as time goes on, and we're seeing more and more the general public be confronted with some of the procedures which are undertaken in livestock as part of the production of their clothing or their food. And I have no doubt that in coming years, the fact that this is an elective surgical procedure on livestock will be called into question. Indeed, this is not something that occurs in Europe really at all. It just wouldn't fly. There's lack of an alternative to this ECG for synchronization, and there's a lack of alternative for FSH, for superovulation. So if those hormones aren't available, whether they can't be made or whether they are in too small a supply, or the ethical issues around their use, all of a sudden we can't do that artificial breeding anymore, which is a very significant problem. Another one was a little bit left field, is there's been increasing reports of poor, or at least unreliable, artificial insemination or ET results with no real explanation. they're anecdotal reports for now, but they sort of centre around South Australia and parts of Western Australia. But they're dotted around the country. And what it's leading to is a waning adoption amongst the seed stock industry, and that has significant flow-on effects for genetic advancement. And when I talk about genetic advancement, when I talk about what's actually at stake if artificial breeding isn't available anymore for sheep, this is a formula which is worth keeping in mind. So this is response to selection. This is, in a way, genetic progress. Now, a bunch of different terms in there. Intensity of selection, heritability, standard deviation of phenotypic variance, generation interval, a whole bunch of things. But what I want you to be aware of is that these various factors, these different letters, they impact our response to selection. And it's through the use of artificial breeding, so artificial insemination, that increases selection intensity of the male. Oops, here. Mowat increases selection intensity of both the male and the female. You've got Jivet, which admittedly isn't used very much, but that decreases the generation interval. But without these tools, we are unable to influence that response to selection to the same degree. And so we'd get dramatically lower genetic advancement and production advancement as a consequence. So it's really important that there is a future for the sheep artificial breeding industry. So for the remainder of the presentation, I'd like to talk about the research that we've undertaken to address these threats to artificial breeding and to try and secure the future of this sheep and goat artificial breeding industry. So that first threat, the alternative to a laparoscopic surgical artificial insemination of frozen semen. So to just reiterate, cervical AI has a variety of benefits in that it's not a surgical procedure. So immediately welfare is not of as great a concern. Beyond that, it's much more accessible. So you don't need to be a veterinarian. You don't need to have the same level of surgical training. And so if you are able to have cervical AI, you would be able to increase the adoption. It means there's more females being inseminated. That increases that selection intensity again. So it's a good thing. However, as we've already said, frozen sperm are unable to navigate that cervix. However, many years ago, it was the late 90s basically, there are experiments done by our research group, by my predecessors here, where they looked at doing cervical artificial insemination with frozen thawed sperm. They also had an intrauterine control, but they exposed that frozen thawed sperm to seminal plasma. So seminal plasma being the acellular component of semen produced by the accessory sex glands. And if you supplemented this frozen thawed sperm with seminal plasma, you got this dramatic increase in pregnancy rate back up to 60-odd%. So approaching those levels of intrauterine fertility. Now, it's a wonderful response and certainly a relatively easy solution to the problem. However, it didn't always work. There was a number of studies which took place after that which showed that sometimes you would get the effect and sometimes you wouldn't. And so we, as a research group, set about exploring this. And basically wanted to get to the bottom of this relationship between seminal plasma and sperm fertility. And it's a complex and complicated relationship. So here we have an image of a testis, and then you've got the epididymis and its various segments, and broken up to 10 segments here, along with the vas deferens, which sit next to it. Now, of those 10 epididymal segments, this is some work done in France in the late 70s, you can see that as it moves through the epididymal segments up to the vas deferens, there is an increase in the motility, and there's also an increase in the fertilization after intrauterine AI, surgical intrauterine AI. But what's curious is that at this point, the sperm have not been exposed to seminal plasma. There is no benefit in this case, in a uterine insemination, to being exposed to seminal plasma. So our hypothesis was that exposure to seminal plasma, perhaps whilst it doesn't do anything or very little in the uterus, it might facilitate normal transit of sperm through the cervix, this particularly selective organ in the u. So we went on to experiment with this. It was actually my first PhD student, Jessica Rickard, who conducted this work, where she utilised a variety of techniques to explore this effect. So the videos you can see now are utilising something called probe-based confocal laser endomicroscopy, which is done with a research group at INRA in France, Dr. Xavier Drouard. We're seeing sperm swimming around at the uterotubal junction in vivo, in a live U, in this video here. Just remarkable footage and a remarkable tool for exploring sperm transit in animals. So anyway, in this series of experiments, epididymal sperm and ejaculated sperm from the same animals were compared for motility, velocity. You can see that they're the same. But with this probe-based confocal laser endomicroscopy, we saw that the number of sperm at the uterotubal junction were much higher if they were ejaculated sperms. This is after cervical AI, incidentally. We then went on to do some fertility trials where we did intrauterine AI with epididymal sperm or epididymal sperm which had been supplemented with seminal plasma, put directly into the uterus, no significant difference, put into the cervix and forcing the sperm to cross the cervix, big difference. You can see that the seminal plasma did indeed facilitate a progress past the cervix. Why? Well, it seems that there is seminal plasma confers some sort of increased ability to penetrate cervical mucus, which is what you can see in this graph here. It also changes some of the membrane-bound glycoproteins. So basically that's the glycocalyx, or the edge of the sperm cells. And it changes the way that these sperm interact with the immune system. So this graph on the far right of your screen, that's showing the percentage of epididymal sperm which adhere to neutrophils and the percentage of ejaculated sperm which do. And you can see that if you've been exposed to seminal plasma, which the ejaculated sperm of course have, they almost have like a cloak of invisibility, or at least a number of them do, which allows them to navigate past or away from, or just not be seen, I suppose is probably the most truthful way of putting it, just not be seen by those neutrophils. So they're not being captured by them and subsequently shunted out back through the reproductive tract. So that was quite an interesting finding, and it all goes towards this working theory that seminal plasma really is key for correct interaction of the sperm with the female. We set about utilising proteomics to investigate the sorts of protein differences that were there on the sperm surface. And even though the seminal plasma of the ram is very, very complex, there's hundreds and hundreds of proteins in there, there's only a handful that are actually conferred to the sperm surface at ejaculation, which was quite interesting. Leg 1, EDIL3, and BSP1 and 5. So we went on to look at supplementation studies and found that we certainly got increased post-thaw motility and velocity by utilising these BSPs. And we went on to attempt to do a cervical transit study where we supplemented epididymal sperm with these BSPs to see whether or not that was the identity of the protein which caused the boost in cervical transit or conferred this cervical transit ability. I won't show the graph. It was a very, very small pilot study at the end of a large funded project, but basically it did not work as expected. Work needs to be redone. Certainly we need to investigate some of these other proteins. But yes, basically that's where that work got to. It's clear that these seminal plasma plays a huge role, that there are specific proteins which are definitely of interest. But yes, we haven't quite solved that issue of cervical transit yet and delivered that different, that alternative to surgical AI. So moving forward to PMSG for synchronization and FSH for superovulation. Or just a little recap about what ECG or PMSG is. So this is something which is produced by the fetal trophoblastic cells of the chorionic girdle in pregnant mares at a certain point in gestation. You can see that gestation interval there. It's a glycoprotein heterodimer similar to LH, FSH, HCG, but it's much more heavily glycosylated, and it's thought that this heavy glycosylation is what gives it its much longer half-life as opposed to FSH. So that's why FSH need multiple injections to get a superovulation response, whereas with ECG, you can just give one injection. As we said before, it's key for sheep artificial breeding. You've got to have this stuff. There's been some recent work to suggest that maybe there is a recombinant ECG product, and if that's the case, then exciting times. Haven't seen that used in Australia yet, but there was some work that was presented at the most recent ICAHLS meeting in Italy earlier this year, and it does look like that may be one of the solutions, so long as they can make enough. But for us, we have recently received some funding through, well, it was with Monash University, that main academic there, Dr. Kelly Walton, that you see down in the bottom left. She received some money from the Australian Research Council. She's just moved to UQ. And we have this grant where we're looking at ways in which to increase the number of follicles which are produced in a cycle, so that you would be able to do away with utilizing PMSG or FSH for stimulation or superovulation, but rather have these targets within the inhibin pathway, which we're able to drug and basically fine-tune using the animal's own biology, force it into producing, 1 ovulation, 20 ovulations, whatever that happens to be. So we've got good preliminary data in mice. There's some work which is going to continue in the mouse model for the next year or so, and then we'll push that over into sheep. But basically, we're hoping that this is going to result in a new means of facilitating superovulation, a new way of synchronizing or stimulating animals. Okay, so the last one is linked to this success or failure of AI. So as I mentioned, a lot of reports have reduced AI or ET success. And it's really hard to track this kind of thing. It's hard to really put a number on it. And it's hard to explain why it might occur, because there are so many factors that influence the success of these programs. There's female factors, so the synchronization method used, the PMSG dose, how much analgesia is given, nutrition, genetics, management, heat, the timing of AI, the weight or the condition score, so many factors. For the male, it's semen quality. Is it fresh semen? Is it frozen semen? Is it a pellet? Is it straw? How many sperm are there? Lots of different things. Now, when we surveyed the breeding companies back in 2016, they thought that it was synchronization and management predominantly which were causing most of these failed programs. But you can see that a number also thought maybe it's environment, maybe it's semen quality. But look, the reality is we've got absolutely no idea. We really don't know what it is. We do know on the semen side of things that there are some minimum standards for processed ram semen, but there's not great data which links these current standards to fertility outcomes. And it's not entirely clear how much these standards are tested for and adhered to by the industry as well. Certainly since this time, many more semen assessment methods, more objective methods have now become available. So with this in mind, we've been fortunate to be funded by Australian Wool Innovation and New South Wales Stud Merino Breeders Association Trust to capture a whole lot of fertility data from their sire evaluation programs, to take all of the ejaculates which are used in those programs from a couple of hundred sires, test those very ejaculates which are used for AI, and then link those in vitro parameters with fertility. And we're also looking at some of those female factors to basically establish a predictive model for AI success. These are just some of the things that we have the possibility of testing for. We're not doing all of these, but we're probably doing about 70% of these various things to see just how they go at offering a predictive value for AI. Now, beyond that, we've recently been trying to think more long-term, beyond these very controlled research studies, to utilize big data where we can capture information which is just normally collected at artificial insemination, and then mirror or marry that up to data at pregnancy scanning. So we developed in collaboration with a company called Graham Innovations in Melbourne, in Australia, and utilising the services and the voluntary efforts of a number of these other companies, people that you see here. We were able to develop this novel hardware and software platform which captures all of that information at AI, uploads it to the cloud. The same hardware software system can be plugged into the ultrasound machine, which is used to diagnose pregnancy in sheep in Australia by these people. And there's good, all 30 million odd sheep which are scanned, but basically this allows automated capture of that data and automatically marries it up to the data coming in from AI for us to potentially mine for AI prediction ability. So that's our big data effort. So just to conclude, we feel that there are real significant threats to the future of sheep artificial breeding, and there's definitely research required to mitigate these risks to AI and ET for that becoming unavailable. We see the future of sheep artificial breeding as being cervical AI with frozen semen, not needing these hormones, PMSG and FSH, getting more predictable or improved AI ET results. We'd like to see improved semen standards, more improved labeling, and just the collection of data being very commonplace. And the overall goal of this is to improve these artificial breeding results and secure the future of this industry to ensure continued genetic progress of sheep in Australia and ultimately throughout the world. So with that, just acknowledge my own research group, a number of collaborators, particularly Xavier Drouard in France, Gordon Rafshoy, New South Wales DPI, Dr. Kelly Walton at the University of Queensland, and Dr. Sean Fair at the University of Limerick in Ireland, a number of artificial breeding companies and funders. Again, sorry that I am not able to answer any questions, but if you do have anything that you'd like to know, you can always get in touch by email or Twitter. It'd be a pleasure to speak to you about any of this. So with that, hope you enjoy the rest of the conference, and I will see you soon. Cheers. Bye.
What an interesting topic.
Okay, and so since the professor wouldn't be able to answer questions, as he said earlier, if anyone has anything to ask him, you could reach him through email or even by Twitter, apparently. And so to briefly summarize the lecture that we just heard, because sheep, due to certain barrier in the cervix, the conventional artificial breeding had a really low success. And therefore, the Professor Simon's lab has been doing some research to addressing or mitigating the risk of AI and ET that is not available that many yet. So those research, including one, searching for the alternative for surgical AI breeding, and two, an alternative to PMSG for synchronizations and FSH for superovulations. And also three, this is apparently also quite important, predicting the success or fail of the artificial inseminations. And the lab, interestingly, went to use the big data analysis to do the prediction for the better future in the genetic progress of sheep artificial breeding. So,
before we close this section, we would like to present Professor Simon with certificate of this wonderful event. And thank you again, Professor Simon.
Also, we would love to thank again for ladies and gentlemen, everyone who had been joining us this morning. And we will now return the stage to the master of the ceremony. Thank you, everyone.
Thank you.
Thank you very much to Dr. Lina and Dr. Hartanto for leading this session. And I would like to say thank you too to Professor Gujang and Professor Simon de Graaf for the amazing presentation. Ladies and gentlemen, before we go to the next session, we would like to take a picture together. So please kindly turn on your camera. And for the commit, please to take a picture. Okay, thank you very much. Ladies and gentlemen, finally we are in a lunch break and poster session. This session is about 30 minutes and the next session will be guided with my friend Tarzan. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to Isaura. Ladies and gentlemen, allow me to introduce myself. My name is Tarshan, and I will be the Master of Ceremony for